So we made it all the way up to the 1912 Nobel Prize in Physics. Now, before we get into this one, if you haven't yet, click the subscribe button so you can get notifications for all the new ones of these as they come up. The 1912 prize went to the guy you see on the screen, Nils Gustaf Dalen, which I'm probably pronouncing wrong, but we're going to let that part go. It was for his invention of an automatic regulator for use in conjunction with gas accumulators for illuminating lighthouses and buoys, which is a pretty obvious kind of, okay, I look at that and I know what it is, but let's look at why that was important enough to win a freaking Nobel Prize. Now, before we get to the work he won the prize for, it's important to note that a lot of these guys didn't grow up thinking, hey, I want to be a physicist, I want to, go off and solve these galactic level problems. They kind of grew up, sort of like everybody else did. I mean, most physicists I meet don't grow up saying, hey, look, this is what I want to do for a living. It somehow you wind up in the field. But this particular gentleman actually grew up and for a while ran a family farm. And one of his first sort of forays into technology was actually in 1892. He invented a milk fat tester, which, if you think about it today, you go to the grocery store, you get 1%, 2% non-fat. It's a pretty simple process. You just go grab it off the shelf, no problem. Back then, they didn't really have a way to actually test it out. So he actually did invent a milk fat tester that allowed you to check for quality of the milk delivered. And that was how he actually worked his way into college, was by using that invention to say, hey, look, I can actually do this kind of stuff. And that led to his career as an inventor and as a physicist. Well, it turns out old Gustav was a little more entrepreneurial than some of the other Nobel laureates around this time frame. And he wasn't just looking for, hey, how can I go off and invent something or create something that's going to change physics? He was looking at practical real-world applications. He was looking at, how do I do something to solve this problem that I can then go build a company around and maybe make some money at? One of the problems at the time with lighthouses and light buoys is they weren't run by electricity like they are today. They were run on liquefied petroleum gas, which couldn't get you as bright of a light as they wanted. They wanted to use acetylene. The trouble is, acetylene, as we'll see in a minute, had its little drawbacks, but he was the first to come up with a way to actually doing that safely, to being able to store it safely, transport it safely, get it out there, get it into the lighthouse, and have it be predictable and volatile. And by volatile, what that usually means to a scientist is it has a tendency to spontaneously combust on occasion. Now, acetylene, when it spontaneously combusts, doesn't just go, oh, poof, I have a little fire. No, it's a little more dramatic than that. Stored improperly and not handled correctly, acetylene tends to look a little bit more like this. So while a ship at sea could certainly see your lighthouse, it does render itself to some questions about the reusability of that lighthouse, when all that lighthouse's job is to do is to mark shallow water. So the Nobel Committee decided that, hey, this was a great idea, this is a great project, and it did make truly reasonable differences all over the world. Now, the safe storage and transportation of volatile gases is still something that's dealt with today in labs all over the world, in automobiles, in you name it. Movement of volatile materials happens around the world every single day. Thank you, and please don't forget to click like and subscribe on the channel. Everybody have a great one. We'll see you on the next Nobel Prize.